Okay, today we are doing chapter 3. This is a much easier chapter than 1 and 2. You're still going to learn new information, but it's going to be a lot more fun to learn it and easier, and you're going to be able to connect it with what you've already learned in chapters 1 and 2. So chapter 3 talks about lead morphology and placement. And again, we're just going to go through your PowerPoints. You can find these PowerPoints on Canvas underneath files, and you can find them there. Don't get these confused with your study modules and your homework site Pearson. That is just additional modules for you, but your PowerPoints are separate. Okay, so electrocardiography is the recording of heart's electrical impulses by way of electrodes on the skin. The right leg electrode is used as a ground electrode. Electrodes or other limbs and chest create leads. More views of the heart's electrical activity, the better chance of recognizing its patterns and abnormalities. This is what we're seeing printed on an EKG. Is called the electrocardiogram. Okay, so the electrocardiography is a recording of the heart, and when it prints on a machine, it is an electrocardiogram. Okay, and your right leg is used for that ground electrode. That's important to know for your certification. And when I talk about electrodes, I'm talking about those sticky pads that they put on the chest to do an EKG. If you have ever seen one done or had one done, or you've seen it in the movies, and they have those round or square stickers on the patient in the hospital or on the ground, that is called an electrode. We have 3 types of leads. So these leads are going to be connected by way of electrodes, okay? The 3 types are bipolar, augmented, and precardial. Your bipolar leads are easy to remember because you have to have 2 limbs, 2 electrodes to make a bipolar lead. Augmented leads and precardial leads only need 1 electrode, 1 limb to make that lead. They're unipolar, meaning 1. Your augmented leads are unipolar leads with a positive pole on 1 limb and using the midway point between the other 2 limbs as a negative reference point. They must have their own printout augmented to record on EKG. The bipolar and augmented leads are also known as your frontal leads. The bipolar and augmented leads are also known as your frontal leads. Precardial leads are your chest leads. There are 6 of them, and they are also unipolar. So we have 3 types of leads: bipolar, augmented, and precardial. Augmented and precardial are both unipolar, meaning there's only 1 lead, and bipolar, we need 2 leads. The augmented has a positive pole on 1 limb and uses a midway point, that's very important for your certification, between the other 2 limbs to get that negative point. There must be a printout augmented to record on EKG. Okay. So let's look at your bipolar leads. We have 3 types of bipolar leads, all with a positive and a negative pole. Lead 1 is from, and everybody do this motion with me, it'll help you remember. Lead 1 is from your right arm to your left arm. Just start at your right shoulder and go to your left. This is lead 1. Lead 1. Your left arm, when you say the Pledge of Allegiance, it is a positive electrode. Okay? So lead 1, your bipolar lead, has to have 2 poles, and it is from your right arm to your left arm. Left arm is positive. Lead 2 is going to be from your right arm, and you're going to go across to your left leg. Go to your thigh. Right arm, left leg. Right arm, left leg. I promise you, if you do these hand motions, you will memorize these leads without any problems. It's usually fun in the class. Everybody's doing them. We wind up dancing. It's kind of hard to do that when we're remote, but it's definitely a way to learn and memorize without actually have to sit there and study. So if you just do these hand motions by the end of this PowerPoint, you won't even have to study, and you're going to know who are your bipolar, your augmented, and your precardial leads. So again, bipolar leads, we have 2 poles. That means 2 electrodes. And lead 1 is right arm, left arm. Lead 2, right arm, left leg, and your left leg is positive when we're referencing lead 2. Lead 3, we're going to go back to my left arm, and we're going to go to my left leg. Left leg is positive. Okay, so if you start right arm to left arm's positive. Right arm to left leg is positive. Left arm to left leg is positive. You'll always know what kind of pole we're looking at for that specific lead. Being the last place you touch, it is going to be positive. And remember, your ground electrode is going to be your right leg. Those are your bipolar leads. So here we go. Again, lead 1, right arm, left arm. Lead 2, right arm, left leg. Lead 3, left arm, left leg. And you see who's positive and who is negative. Now remember, when we talk about positive and negative, we've already talked about this quite a bit, especially to get that conduction system going, that electricity current, that spark, that flame to get going. We need sodium and potassium to cross each other, a positive and a negative, right? Same thing with here. For us to be able to read a signal from the electrodes on the patient to the EKG machine, we need to have a positive and a negative pole to see those. So if you were to take these leads 1, 2, and 3, and join them at the middle, you're going to get what's called a triaxial diagram. This is just something you just have to remember. If I was to connect leads 1, leads 2, and lead 3 in the center, what kind of diagram am I going to get? That's 3 leads connected in the middle. We're going to get a triaxial diagram. And it almost symbolizes your motions. Lead 1 is going across, lead 2 up and down, and lead 3 up and down. So if I was to join these 3 leads, these bipolar leads, which contain 2 poles at the middle, I would get a triaxial diagram. So then we have what's called Einthoven's triangle. This is formed by joining the lines representing the leads 1, 2, and 3, your bipolar leads, at their end. So again, if I join leads 1, 2, and 3, which are bipolar with 2 poles, in the middle, I'm going to get a triaxial diagram. But if I were to join them at their ends, I'm going to get what's called Einthoven's triangle. William Einthoven stated that lead 1 plus lead 3 equals lead 2. Listen very clearly. He stated lead 1 plus lead 3 will equal lead 2. We're talking about the length and the height. This is the height of the QRS in lead 1 added to the QRS in lead 3 will equal the height of the QRS in lead 2. If you remember in chapter 2, we talked about QRSs, which represents ventricular depolarization and is the spike on your rhythm. If I were to measure the height, remember, how do we measure height? By those little bitty boxes is the amplitude and the height going up and down, vertical. But if I were to count them boxes left to right, horizontal, I would get my time interval. But if I were to measure the QRSs in lead 1, lead 3, and add them together, they should equal the QRS in lead 2. And I am adding them up. I am measuring the boxes on how many boxes is the length of that QRS, that spike. This can help determine if the EKG is truly abnormal or if the leads were inadvertently placed on the wrong limbs. Now, what's interesting about this is when you start placing these leads on the patients, the majority of the machines today are going to tell you what electrode, what lead to place it on, and it will tell you what limb is wrong. So you're not technically having to go and do all these measurements. But for your certification test purposes, you need to know this rule. And it may ask you, what is Einthoven's rule? His rule is that the QRS height in lead 1 plus lead 3 will equal the height in lead 2. It also says that the lines are joined at their ends is going to create Einthoven's triangle. So you have Einthoven's triangle and Einthoven's law. And these are all dealing with what type of leads? Bipolar leads, having 2 poles. And who's my ground lead? My right leg. And where is lead 1? Right arm, left arm. Where is lead 2? Right arm, left leg. Where is lead 3? Left arm, left leg. Who is positive? If I'm in lead 1, my left arm. Lead 2, left leg. Lead 3, left leg. And here's the triangle. Again, you'll notice if you can visualize your shoulders, lead 1 is where? Right to left. Lead 2 across. Lead 3 up and down. Einthoven's triangle. And this is his law, and it's saying, again, if we were to count, and I'm going to try to draw again, I'm not great at it. If we were to count these little bitty boxes right here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is counting up, which gives us the height and the amplitude. And there they have 11. Let me count that again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I counted those little boxes going up, and I got 11 mm tall. What is mm? Millimeter. So remember, in chapter 2, one little bitty box is 1 millimeter all around. The width and diameter and the height. So then we're going to look at lead 3, I'm sorry. Count the little boxes from the baseline going up. 1, 2, 3, 4, 5, and 6. 11 plus 6 equals 17. So let's see if we have 17 in lead 2. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. There you go. Now you notice 17 did not fully fill that last box, but we still counted it. You're going to notice that there is no accurate, precise answer. Some of you will be a half a box off or 1 box off, depending on how you are counting. Okay? That's coming up when we get to chapter 7, I believe. Alright, moving on. So we've talked about bipolar leads. Now let's talk about augmented leads, which are unipolar, which means there's only 1 electrode and 1 pole. The thing about augmented is they're going to use the midpoint between 2 other poles to get that negative reference, because we need a positive and a negative to get a charge and to see that electrocardiogram printed out. So our 3 poles are called AVR, AVL, and AVF. Guess what? You already know them. AVR is my right arm. AVL is my left arm. And AVF, F is for femur or for foot, is my left leg. So AVR measures the current traveling towards my right arm. AVL measures the current going towards my left arm, and AVF is going to measure the current going to where my leg. Now, if I am going towards a positive pole, okay, so lead 1, is from right arm to left arm. Where is my positive pull? My right arm. Where is my negative pull? My left arm. If I'm going towards my left arm, a negative pull, my QRS is going to show negative on the electrocardiogram, the printed out EKG. But if that current is going towards a positive pole, which is my right arm, that QRS is going to show a positive deflection, which is a picture. Okay. Also, so we know that my right leg is negative, and that is ground. But remember, and now I'm talking about your bipolar leads, I'm going back real quick. Remember that my right arm to my left arm is going to be lead 1, and I'm going to have a positive over here. And my right arm to my left leg is lead 2. Is lead 2, and I'm going to have a positive leg. And then my lead 3 is from my left arm to my left leg, which also gives me that positive charge, and this is lead 3. So for my bipolar leads, if I am positive on my left side, then I have what kind of charge on my right side? Negative, because you have to have that positive and that negative. For lead 2, again, if I am positive on my left side, on the other end I need to have a negative. And then for lead 3, if I am positive here, I need to be negative here. So notice that you can't just memorize these charges and their locations, because it depends what lead you're looking at. A lead is the signal, the electrocardiogram, the deflection, the EKG rhythm, your PQRST, that we get of the heart, getting that conduction electrical current of the heart and printing it out on that electrocardiogram. So if I am looking at lead 1, my negative pole is going to be my right arm, and my positive pole is going to be my left arm. But if I am looking at the lead AVR, what is my charge on the right arm? Positive. Okay? If I'm looking at lead 2, my right arm to my left leg, my right arm remains positive and my left leg is positive, but my right arm is remaining positive as well. And lead 3, same thing. So if I have a negative charge over here on my left arm, that means my right arm has what kind of charge? Positive. Okay? So if you don't understand that, please rewind, re-listen, because this is something very easy to get confused on. It depends on what lead you're looking at, on what charge that limb has, that electrode has. Okay? Alright, so augmented leads, you need to know what AV stands for, which is augmented voltage. And you learn throughout this course, and if you've had a medical course before, you have to know a lot of abbreviations. Because, you can imagine when you're in the field and working and you're writing notes, are you going to sit there and write out augmented voltage, or are you just going to abbreviate it and put AV? So your augmented leads is abbreviated as a lowercase a and a capital V. The last letter refers to location of the positive pole. So check this out. If it was AVR, where's your positive pole? Right arm. AVL, where is your positive pole? Left arm. And AVF refers to the left foot or the leg, and I like to think femur because it's an F, which is where you'll find that positive pole. So if you have a hard time remembering lead 1, lead 2, and lead 3, the thing to remember is when you finish that lead, you end up positive. So lead 1, right arm, left arm is positive. Lead 2, right arm, left leg is positive. Lead 3, left arm, left leg is positive. And then for your augmented leads, it depends on what's behind it. AVR, AVL, or AVF. If it's AVR, your right arm is positive. If it's AVL, it's your left arm that's positive, and AVF is your left leg that is positive. If you join, so just like my bipolar leads, I can get a triaxial diagram. It's the same thing for my augmented leads. If I were to join these 3 leads, AVR, AVL, and AVF, in the middle, you're going to get a triaxial diagram. If all the frontal leads, well, who are the frontal leads? Did we talk about frontal leads? Yes, that's combining, that's your leads 1, 2, and 3, and your augmented leads, AVR, AVL, and AVF. If I took all of those leads and joined them at their center, I am now going to get a hexiaxial diagram, meaning 6. 6 leads are going to connect in the center, and I'm going to get hexi. Who are my frontal leads? Your bipolar leads, which are leads 1, 2, and 3, and your augmented leads, which are AVR, AVL, and AVF. Here you go. We've combined them at the center. This is going to be my triaxial diagram because we only have how many? 3 leads. And where are they joining at? In the center. Okay? Now, don't try and draw this on your own. It's very difficult. If I were to connect all of my frontal leads at the center, that's going to give me my hexiaxial diagram, which is 6. And here are they. Here's lead 1, lead 2, lead 3, AVR, AVF, and AVL. Gives me a hexiaxial diagram. And remember, Einthoven's triangle is like this, which is leads 1, leads 2, and leads 3. That leaves us with your precardial chest leads. These are located on the chest. They are unipolar, just like augmented, they're unipolar, and each one is going to be a positive electrode. So this is going to provide a wraparound view of the heart from the horizontal plane. So we're getting as many angles as we possibly can of the heart. And these are known as our chest leads. Precardial, they're unipolar, one positive pole. And they're easy to remember. They're V1 through V6. V1, V2, V3, V4, V5, and V6. Alright, so where do we place these stickers at, these electrodes, to get these leads? You need to know, first of all, the anatomy of the body. So my frontal leads are the front, right? They're gonna be connected by what's known as your limb leads. You're gonna have 4 of them, and they're gonna go on each arm and each leg, and that's gonna be your electrodes. And then for my chest leads, they're gonna go like it's showing in the image right here. V1 through V6 on the chest. So you'll notice V1 right here. It is on the on the right side of my sternum, and V2 is on the left side of my sternum, and then V3 through V6 is all on the left side. So think about your Pledge of Allegiance. You put your hand over your heart. Even though our heart is more centered than it is over the left, it leans more towards the left, which is why we're going to look at these 6 views on the left. Right here, you're going to count your ribs. So if you count the very first bone under your clavicle, everybody do this. Find your clavicle and find the next hard structure underneath your clavicle. That is your first rib. And you can feel that little space. That space right underneath your first rib is called your intercostal space. And then you're going to feel another hard substance. That's your second rib, second intercostal space, third rib, third intercostal space, fourth rib, and so on. So that was lead 1, lead 2, lead 3. Now notice your fourth rib, right underneath it is your fourth intercostal space, and that's where we want to get V1. And then notice, so this is the same for V2, fourth intercostal space. If that's my fourth rib, this one over here is my fifth, and then we have my fifth intercostal space. So V1 and V2, where are they going to be put on your patient? On your fourth intercostal space. And then V3 through V6 are going to be on your fifth intercostal space. So this is just going to give it to you, and notice it's already abbreviated for you. So your fourth intercostal space, ICS, is the right sternal border, RSB. The space below the fourth rib where it joins with the sternum on the patient's right side. Its location is abbreviated by fourth ICS, RSB. V2 is also going to be on that fourth intercostal space, but it's now going to be on your left sternal border. V3 is going to be in between V2 and V4, right? That's common. V3, it's a rule of thumb, you just go the middle of your clavicle and bring it right down to that space, and that should be where V3 lines up. Also, sometimes you can imagine the nipple on a patient and measure it. That would be where you would want V3 to go. Not on the nipple, but lined up with the nipple underneath on that fourth intercostal space. I'm sorry, fifth intercostal space, because we're talking about V3. V4, fifth intercostal space. V5, fifth intercostal space. V6, fifth intercostal space. Now notice your abbreviations. V4 is your mid-clavicular line. V5 is your anterior axillary line. What is axillary? That is medical terminology for armpit. So it is the front. Anterior means front. The front of your armpit. And then V6 is going to be the mid-axillary line, which is the mid-armpit. And again, this is just locations to measure. You're not going to put the electrode on their armpit or on their nipple or on their clavicle. You're just measuring a reference to where to put that electrode on the fifth intercostal space. Intercostal spaces are your spaces in between your ribs. If you have trouble feeling your own, so you start with your clavicle, find your first rib, feel underneath it, that's intercostal space 1, second rib, intercostal space 2, and so forth. If you have trouble feeling that, if you have children, especially younger children, my daughter is 5, and she's very, very easy to feel her ribs. My nephew is 6, and I was able to feel his as well. Now my daughter is going on 14, and she's a little harder to feel those intercostal spaces. But if you have kids, feel on them. Even if you have animals, you can feel their ribs. Don't press too hard. And if you're still having trouble trying to figure out what's a rib and what is that intercostal space, you can always go to the grocery and get, I don't know if it's called a stack of ribs, and it's the same thing when the ribs are lined up and you can feel in between the spaces. Alright, so continuous monitoring. So now that you have an idea, so we know what the heart does in chapter 1, and we know all the parts of the heart and the anatomy and the physiology. And then in chapter 2, we learn that our heart can create its own electrical current, conduction. And it has pacemaker cells, contractile cells, and conduction cells, right? And in this chapter, we just learned where do you place the leads so that you can read this rhythm, and you need to have those negative and positive poles. And our machine's going to tell us where to put it as well. Well, why do we need to know all that? Well, we want to monitor a patient's heart. Maybe somebody goes into the ER, says that they're having trouble, they feel like they're having a heart attack all the time, they get an EKG done, nothing shows out of the normal, everything looks regular, but they still feel as though they're having symptoms of a heart attack. Well, then we can place them on a monitoring system. Or let's say they are in the early stages of a heart attack. We can place them in a bedside where they can be monitored as well. And that's where we're going to constantly watch these rhythms. And you already know that your rhythms, there's rules, right? You have your PDR interval, your QRS interval, and your QT interval. And we also have Einthoven's law. So let's talk about monitoring. Bedside monitoring is when the patient is going to be attached to an EKG machine by a 3-lead or a 5-lead cable. So we're talking electrodes is those stickers that you put on, right? But the lead, it's either going to be unipolar, augmented, or precardial, or bipolar, which is leads 1, leads 2, and lead 3, depending on what device they're using. This is known as your bedside monitoring. Telemetry, that is going to be a remote cardiac monitoring of ambulatory patients. So if a patient is ambulatory, meaning they're moving around, it could be taken on an ambulance, but it could be a monitor attached to them for daily living for maybe 48 hours. This is known as telemetry. Requires altered electrode placement to allow for freedom of movement and to minimize artifact. What is an artifact? An artifact is something that gives us a false reading, a false interpretation, a false rhythm. So let's say, and you'll see this coming up in the next chapters, let's say somebody is brushing their teeth and they have an electrode on that side, that right arm and that left arm, whether they're right-handed or left-handed. Well, when they have a motion going up and down, that's going to signal the monitor that that patient could be going into a heart attack. So this would be known as an artifact because we all know that that patient was just brushing their teeth. So sometimes it requires the altered electrode placement to allow freedom from movement and to minimize artifacts. So we all seen this on TV, right? Or you've seen it if you went and visit somebody who was ill. This is what your bedside monitor might look like. Notice you can kind of depict already your QRSs, and it looks like there's 3 different leads showing here. And it looks like this patient could possibly have a pacemaker. So this is an example of your bedside monitor. Okay. And then just some little hints here is what are the most commonly used leads for continuous monitoring. So somebody who may need to be monitored for a couple of hours or for 24 hours or for 48 hours. What are the common leads that we're going to look at? So remember, back in chapter 2, you can have 12 different views, a 12 lead. What is the preferred lead to look at a patient's monitored rhythm that we can see? Is there something going on with this patient that we need to be alerted about? And that is going to be leads 2, which lead 2, remember, is your right arm to your left leg. So if we're looking, what is the midpoint in between my right arm and my left leg? What lead is going to be in between? V1, because it's on the right side of my sternum. Lead 2 is by far the most commonly utilized lead for continuous monitoring. The MCL1, which is also known as V1, its midclavicular line, is useful for assessing rhythms with a wide QRS, as it can help pinpoint abnormalities in ventricular conduction. So we're looking for something that's not normal, and we're talking about ventricular conduction. What is your ventricles? We're talking about your bottom chambers of the heart. And what is conduction? The electrical current. Remember, your conductor. You're conducting traffic, right? So you're passing along that electrical spark, that signal, depolarization. So what lead would we look at for continuous monitoring, which is lead 2 and V1. Lead 2 is my bipolar lead. V1 is my precardial lead. Lead 2 has a positive and negative pole. V1 has a positive pole. So this can get a little bit more confusing if you didn't understand your negative and positive poles for both your bipolar and your augmented leads. So if we're looking at lead placement for continuous monitoring, this is what my poles are going to look like. We said we're going to pay attention to lead 1, which is right here. And we're going to look at V1, in other words, MCL1, and V1 is going to be right here. But we know that it's going to be just a little bit further up on the right side of that sternum. So what happens here, if I'm looking at lead 2, my right arm is positive. Lead 1 to lead, lead 1 to lead, right arm to left leg is going to give me a positive pole, which means who needs to be on the other side of that positive? A negative. And who is going to be the ground pole, which is going to be my left arm. And when I'm looking at MCL1, we're looking at this positive pole right here, which we know is V1 and is located on the right side of the sternum. And it's positive, so who needs to be, what charge do we need to have? Across, negative, and then that makes my right arm ground. Okay? Alright, almost done. So here's some electrocardiographic truths. So when we're talking about cardiographic, we're talking about a picture, right? Photograph, you take a picture. We're looking at the picture on the monitor. And when we print out that picture, we're going to get an electrocardiogram. I always think of like when you're in school and they have like telegrams, or for Valentine's, you can always give a gram to your friends or something. That helps me remember the difference between the electrocardiograph and the electrocardiogram. So what are some electrocardiographic truths? Positive QRSs are written by the impulse traveling towards the positive electrode. So again, if I'm lead 1, my right arm to my left arm, and my left arm is positive, that means my right arm is negative. And if I see an impulse that started in my sinus node, which is my right side, and it's going to my left atrium on my left side, what kind of deflection am I going to have? And it's going to be negative because my left side, my left arm, has a negative pole. A negative QRS is the impulse traveling away from the positive pole. So then if my signal, if I'm in lead 2 and my left leg is positive, and my spark, my impulse, my electricity, my conduction system is traveling down to my ventricles, I'm going down towards my left leg, which is positive and gives me that positive deflection. The isoelectric QRS from the impulse traveling perpendicular to a positive pole. So if my right arm is positive and my left arm is positive, and I take that electrocardiograph when that impulse is right in between, I'm not going to get more positive or more negative QRS deflection, and instead I'm going to get isoelectric, meaning both sides of that number line, that baseline, have an equal amount of QRS on both sides. And if I get a flat line, which is like this, I will get a flat line written when there is no impulse at all. Now, this is your discussion question for this week. So be careful that you fully understand what a flat line represents, no impulse, and how it affects the heart mechanically and depolarizing and repolarizing. And make sure you know what depolarize and repolarize mean. So here we go. So imagine this is my right arm, and this is my left arm. And let's say we're looking at lead 1, right arm to left arm is positive. Notice my QRS on my right arm, it is negative, and my QRS on my left arm is positive. But my QRS dead in the middle is going to give me half positive and half negative. And that's when we get your different complexes. You get your QS, your RS, your RSR prime, and so forth. So what are normal deflections of the QRS? Leads 1, 2, and 3, AVL and AVF should be positive. This is very important. It's going to come back at you in EKG 2, and if you don't memorize now, it's going to be a little more stressful when you get to EKG 2 because you're going to have to relearn all this information. Same thing with your lead placements and your positive, negative poles. You want to sink it into your head now, because come August when you get into EKG 2 and we discuss these, if you did not memorize them now, you're going to have to relearn this entire chapter again for EKG 2 for chapter 13. Okay? So, normal QRS deflections. Remember, what does deflection mean? That means a picture or an image. Leads 1, 2, and 3, AVL and AVF should always have a positive QRS. AVR's QRS's complexes should be negative. And normal vector of the heart current is top to bottom and right to left. What is a vector? That is the arrow depicting the direction of the current flow. So if you remember in chapter 1 and in chapter 2, we talked about the flow of the heart. We know the heart is divided into 4 chambers, and we know that we're going to start our electrical conduction system at the SA node, and then it's going to go over into the left side and eventually go to the AV node, and then eventually go to the bundle of His where it splits into left and right sides. Okay? So, if my leads 1, 2, 3, and AVF are positive, I'm going to have a positive QRS, but AVR complexes should be negative. So if I am looking at lead 1, which is this one right here, from my right arm to my left arm, and I am, let's say I'm over here, I'm going to have a negative deflection, but if I'm over here, I'm going to have a positive deflection, and in the middle, I'm going to have some positive and some negative. I'm going to be isoelectric. Well, that arrow, if I am more negative, then that vector is going to be pointing towards the left arm. And if I am more, I'm sorry, that was more positive. I'm more negative, I'm going to be pointing to the right arm. Okay, so the current normally starts in the sinus node, which we've just said, in the right atrium, and it terminates in the left ventricle. So a lot of times I get questions. It's kind of hard when we're not in class because I don't get this question right now. But if you were in the classroom, somebody would ask, well, what happens to that spark when it gets to the end of the ventricles? It terminates. It goes away. And then your heartbeat starts all over again. And here's that vector. Here's your heart. So if you have to draw the heart image to see it, there's your heart. It's more so on the left side than it is on the right side. And if in this one in particular, notice we're pointing down this way, which means what lead are we looking at? Lead 2, which is my right arm to my left leg. Okay, so this is showing you your poles. Again, if I'm looking at lead 1, over here is negative, here is positive. If I'm looking at lead 2, negative and positive. And then if I'm going to come to lead 3, I'm going to be positive down here as well. So if I am going towards, notice I have a positive pole here, and a positive pole here. And that current is coming from my sinus node here. From a negative, I'm going towards a positive. I'm going to get a positive deflection. And again, what leads are normally, we're going to have a positive deflection, leads 1, 2, 3, AVL and AVF. Okay? Now this doesn't give you too good of an image, but it's showing you that your right arm is positive. So if my right arm is positive, that means my left arm is negative. And if that signal is going towards my left side, and this of course would still remain positive, but if I'm going towards my left side, that electrode down here is pretty far away, so I'm going more closer towards my negative electrode, which is going to give me a negative deflection. Alright, here's your precardial leads. We've already talked about their V1 through V6. But what should their QRS look like when it prints out in these leads? Well, V1 and V2 are going to be negative. Again, this is information that's going to come back to bite you in EKG 2 if you do not learn it now. You'll have to learn this whole chapter again. V3 and V4, look at this, half up and half down. Why? Because remember, if I'm negative on my right arm and positive on my left arm, and I take that EKG picture, that electrocardiograph, when that signal is in between my right and left atrium, that sinus node, that conduction, I'm going to get a QRS is half up and half down, which means it is isoelectric. And then V5 and V6 should be positive. A good way to remember these, and I'm not sure if it's on the next slide, is to draw out your 12 lead, which we've talked about in chapter 2. Leads 1, lead 2, lead 3, and remember the bottom is going to be lead 2, AVR, AVL, AVF, and we're going to have V1, V2, V3, V4, whoa, let me try that one again, whoa, V5, and V6. So this is telling me that V1 and V2 should be negative, but V3 and V4 should be half and half. We're talking about my QRSs here. V5 and V6 should be positive. And then all of these, 1, 2, and 3, AVL and AVF, I believe, should all have positive deflections. And don't forget Einthoven's law, which means lead 1 plus lead 3 is going to equal lead 2. So the QRS in lead 1, the QRS in lead 1, that's a bad choice of color, plus the QRS in lead 3 should equal the QRS in lead 2. How do I measure that? The amplitude, counting the little boxes going up. Oh, it didn't show it on the next slide. Alright, precardial leads. In V1, septal and right ventricular depolarization send the current towards the positive electrode, resulting in a positive deflection. V1 should have a small R wave and a deep S wave. When we're talking about R wave and S wave, we're talking about the QRS. So remember, my Q and my S are always going to have negative, or unless depending on what lead we're looking at, and my R is going to be positive. So that V1 should have a small r and a deep S. So it's going to look something like this. Deep S. Complex is, which means this is what? Negative. Complex is mostly negative because most of the heart's current is traveling towards the left ventricle. There you go. In V6, the impulse is heading away from the positive electrode during septal and right ventricular depolarization, then towards the electrode during left ventricular activation. Other leads between V1 and V6 show a gradual transition from a negative to a positive. So we know that V1, we are going to be negative, but by the time we get to V6, we need to be positive. And there's your deflection for V6, which is positive. And just to remind you, how do you count for Einthoven's law? These little boxes, lead 1's boxes should, plus lead 3 boxes should equal the height of lead 2. Just a reminder. And here you go. So, again, the best way to learn is write it out, draw it out, and you'll have a better understanding. But this is showing you the direction, which is your vector, this arrow right here, of the electrical impulse. If I'm in lead 1, I am positive. Lead 2, I lost my mouse, positive. Lead 3, positive. Lead 4, AVR, negative. AVL is positive. AVF is positive. V1 negative, V2 negative, but V3 isoelectric, V4 isoelectric, which is half on both sides, positive and negative. V5 is going to be positive, V6 positive. So I started in V1 out negative, and I ended up positive in V6. And also my QRS is isoelectric in V3 and V4. The only negative is AVR, and everybody else is going to be positive in V2.